A city raises its toll on a bridge it owns in hopes of raising more revenue, but revenue declines. How could that happen? How can a city know whether it should raise its toll or lower it? The concept of price elasticity of demand can help you answer these questions. In one of the previous lectures, we explored the law of demand. When price increases, quantity demanded decreases. Now we are going to explore by how much. Elasticity is a measure of responsiveness. We will explore 4 different types of elasticities in the videos for this course. In this video, we are focusing on the price elasticity of demand, which is a measure of how responsive consumers are to a price change. If we say that the price elasticity of demand is elastic, we mean that consumers are responsive to a price change. The force from a bungee jumper is the price change. The stretch in the bungee cord is the resulting change in quantity demanded. If demand is elastic, a relatively small change in price will bring about a big change in quantity demanded. There is a lot of stretch from a small force. Imagine bungee jumping with this steel cable. When we say that the price elasticity of demand is inelastic, we mean that consumers are not very responsive to a price change. When there is a force, which is to say a price change, there is not much stretch, which is to say there is not much of a change in quantity demanded. The equation for price elasticity of demand is the percent change in Q over the percent change in price. Since by definition, price elasticity of demand is elastic when the percent change in quantity, in absolute value, is greater than the absolute value of the percent change in price, the elasticity coefficient will be less than -1. When the absolute value of the percent change in price is equal to the absolute value of the percent change in quantity demanded, the elasticity coefficient is -1. And we say demand elasticity is unit elastic. When price elasticity of demand is inelastic, the price change outweighs the quantity change, so the coefficient will be greater than -1. So along the number line, when the elasticity coefficient is 0, we say that the price elasticity of demand is perfectly inelastic. Here, consumers are not responsive to a price change at all. For the fractions between 0 and -1, price elasticity of demand is inelastic. At a coefficient of -1, elasticity is unit elastic. And then at values between -1 and -infinity, elasticity of demand is elastic. If the coefficient is -infinity, then the price elasticity of demand is perfectly elastic. This graph depicts Casey Jones's personal demand curve for crack cocaine. Why would this demand curve make sense for crack cocaine? You can see that as price changes, the amount of cocaine that Casey plans to buy does not change. His demand is perfectly inelastic. He is not responsive at all to a price change. What would be a good example of perfectly elastic demand? Here is the demand curve that farmer Shauna faces for her organic carrot juice. Shauna thinks her carrot juice is pretty special. She extols its virtues as everything from a laxative to a cure for colon cancer. However, in reality, it is exactly the same thing produced by hundreds of other carrot juice producers. Since carrot juice is carrot juice, and consumers know this, no producer is able to charge more than all the others. This demand curve shows that Shauna can sell as much as she wants at the going market price for carrot juice, but if she raises her price by just 1 penny, quantity demanded will drop to 0. So here, consumers are infinitely responsive to a price change. This is because there are so many other farmers producing a perfectly identical product to the one that farmer Shauna produces. Suppose that when the price of sushi increases 10%, that quantity demanded decreases 2%. What is the price elasticity of demand? Please solve this problem. To solve this, simply substitute the percent change in price and the percent change in quantity into the equation of elasticity. Since there was a decrease in quantity, we enter the percent change in quantity demanded as a negative number. The answer is -0.2. Since the elasticity coefficient is greater than -1, this implies that the elasticity of demand is inelastic. Back to our toll bridge example. The city raised its price in hopes of raising more revenue. However, revenue decreased. Why is this? Was the price elasticity of demand elastic, inelastic, or unit elastic? Take a second and answer this question. It must be that drivers had other options. When the city raised the toll, consumers went a different route or started working from home or something. The consumers were able to be relatively responsive to the price change because they had other options. So, was the price elasticity of demand elastic or inelastic? It was elastic. The change in quantity demanded outweighed the change in price. Generally, the more substitutes a good or service has, the more elastic the demand will be. This is because when there are more substitutes, consumers are able to be more responsive to a price change. The consumer has more options. So what is more elastic? The demand for all toothpaste or the demand for just one specific brand of toothpaste? Take a minute and answer this question. Well, which has more substitutes? All toothpaste or one specific brand of toothpaste? If the price of all toothpaste increases, you don't have a lot of options. So until you get married, you're going to have a hard time cutting back on toothpaste regardless of how high the price gets. On the other hand, if the price of one brand of toothpaste increases, you have other options. This is a narrower definition of the toothpaste market. So, narrower the definition of the market, the more substitutes and the more elastic. Demand for a specific brand of toothpaste is more elastic than the demand for all toothpaste. When the price of the toll increases, which will be more price elastic? The demand for the toll bridge this week or in 6 months from now? Remember that elasticity is a measure of responsiveness, and more responsive means more elastic. When the toll increases, when do you think you'll be able to be most responsive? This week or in 6 months? Chances are in 6 months. This is because for most goods, more time means more elastic. When the price of the toll first increases, you may not have very many options to avoid the toll. However, give you some time and you may be able to arrange for a carpool, to take public transportation, or to work from home, and thus avoid paying the toll. But not all goods. It turns out that the relationship between price elasticity of demand and time is very different for durable goods. A durable good is a good that lasts 2 years or longer, like a Twinkie or a piece of leftover pizza under your roommate's bed. Here, more time means less elastic. This suggests that you have less options to respond to a price change with more time. How could that be? Suppose that you're planning on buying a brand new car within the next 6 months, and suddenly the price of all automobiles increases 50%. Wow, you are suddenly thinking the old Willys panel wagon you are driving is just fine. Who cares about the exhaust coming up through the floorboards when you are stopped at a red light? You're going to make it work. However, with time, the old truck keeps wearing out. The number of things wrong with it just keep increasing. After a while, you break down and go buy a new car despite the fact prices are still up 50%. So you were most elastic in the short run. When the price first increased, you changed your plans from buying a car to not. But after a year, you followed through with your original plan to buy a brand new car. For durable goods, more time often means less elastic. Let's explore the relationship between price elasticity of demand and total revenue more. In our example of the city toll bridge, price elasticity of demand was elastic, so when price was increased, total revenue went down. Why is this? Well, if demand is elastic, then a relatively small change in price will bring about a relatively large change in quantity demanded. Total revenue is equal to price times quantity. If price is increased, there will be an even bigger decrease in quantity demanded. Here the length of the arrows represents the relative magnitude of the change. Since the quantity change dominates the price change, total revenue will go in the same direction as quantity. Total revenue will decrease. For a price decrease, everything is opposite. The price decreases, consumers are relatively responsive, so the price decrease brings about an increase in total revenue. When price elasticity of demand is relatively inelastic, consumers are not very responsive to a price change. Thus, a relatively large price change will bring about a relatively small change in quantity demanded. Since the price change dominates, total revenue will go in the same direction as price. If we cut price, we do not gain many consumers. So when we lower price, total revenue goes down. This is the opposite of what happened when demand was elastic. If we increase price, we do not lose many consumers. So total revenue increases. It goes up with price. Earlier we stated that the elasticity coefficient is equal to the percent change in quantity demanded over the percent change in price. This can be rewritten as the change in Q over the change in P times P over Q. This form is very helpful when dealing with demand equations because the change in Q over the change in P is the slope coefficient for a demand function. Suppose that demand for pepperoni pizza near campus is given by Q equals 10 minus 1/2 P. What will be the price elasticity of demand if the price of pizza is $15? If we plug 15 into the demand equation, we get that Q will be 2.5 thousand pizzas when the price is 15. Since negative 1/2 is the slope of the demand equation, the change in Q over the change in P is negative 1/2. Every time price goes up by $1, the quantity demanded goes down by 1/2. Plugging in for the slope coefficient and price and quantity in the elasticity equation, we get that the price elasticity of demand is negative 3. So when the price of pizza is 15, the quantity will be 2.5 thousand, and the price elasticity of demand will be negative 3. What does an elasticity of demand of negative 3 mean? First off, we can see that the demand is elastic. Knowing this, if the pizza price decreases, what will happen to total revenue? Total revenue will increase because consumers are relatively responsive to a price change. If price drops, the increase in consumption will more than compensate for the drop in price. Suppose that the price drops by 5%. By how much will quantity demanded change? We can evaluate this by rearranging the elasticity equation. The percent change in quantity is equal to the elasticity of demand times the percent change in price. So, if the elasticity of demand is negative 3, a 5% decrease in price will lead to a 15% increase in quantity demanded. Now suppose that the price of pizza is $5. What is the price elasticity of demand? Go ahead and take a minute to solve this problem. Okay, let's go ahead and solve this problem. If we plug $5 into the demand equation, we get a quantity of 7.5 thousand pizzas. Since negative 1/2 is the slope in the demand equation, the change in Q over the change in P is still negative 1/2. Plugging in for the slope coefficient and price and quantity in the elasticity equation, we get that the price elasticity of demand is negative 1/3. So when the price of pizza is $5, the quantity will be 7.5 thousand, and the price elasticity of demand will be negative 1/3. This implies that the elasticity of demand is inelastic. Knowing this, if the pizza price decreases, what will happen to total revenue? Total revenue will decrease because consumers are relatively unresponsive to a price change. If price drops, there will not be much of an increase in quantity demanded. Let's suppose again that the price drops by 5%. By how much will quantity demanded change? Please take a minute and solve this problem. The percent change in quantity is equal to the elasticity of demand times the percent change in price. So if the elasticity of demand is negative 1/3, a 5% decrease in price will lead to a 1.67% increase in quantity demanded. Since consumers are not very responsive to a price change, you can see that the price cut will now decrease total revenue. Let's solve one more. If the price is $10, what is the price elasticity of demand? The answer is negative 1. It is unit elastic. To solve this, we plug our price and quantity along with the slope for the demand curve into our equation for elasticity and solve. One of the things this exercise has illustrated is that for a linear downward sloping demand curve, elasticity changes as you change price and move along the demand curve. So how a price change affects total revenue will depend where on the demand curve you are at. The middle of any downward sloping linear demand curve is unit elastic. This is where total revenue is maximized. You can see this in the lower graph. In the upper portion of the demand curve, demand is relatively elastic. In the lower half of the demand curve, demand is relatively inelastic. Suppose the price charged was $20. You can see in the graph that at $20, quantity demanded is 0. For this reason, total revenue is 0. Consumers are not buying anything. As the price drops, quantity demanded increases, and since demand elasticity is elastic, total revenue increases. In this top portion of the demand curve, consumers are very responsive to a price decrease, so any decrease in price is more than made up for in an increase in consumption, so total revenue increases. The increases in total revenue from a decrease in price end once the demand is unit elastic. This is where total revenue is maximized. Beyond this point, total revenue decreases when price is decreased. In the lower portion of the demand curve, demand is inelastic, so consumers are not very responsive to a price change. The firm has to drop the price by a relatively large amount to get a small increase in price. Once the price is zero, total revenue is zero. Suppose the university would like to increase its revenue and asks you whether it should increase the price of its tuition. If demand is inelastic, what should you recommend? The correct answer is increase price. If the demand is inelastic, that means that students are not very responsive to a price change. When the price of tuition is increased, there is not much of a response from students. That is, most keep attending even after the price increases. Let's work another problem. What is more elastic, demand for gas this week or in 6 months from now? Suppose that the price of gas doubles and stays up. When do you think you'll be most responsive, this week or in 6 months from now? The more time you have, the more options you can come up with. So more time generally means more elastic. When the price of gasoline first goes up, there is not much you can do to get around it. You work where you work, you live where you live, you are dating who you are dating. You are stuck driving between work, home, and your girl or boyfriend's place. However, after some time, you can start making changes in these things. You can change jobs, start carpooling, buy a Tesla, or get a new girl or boyfriend that lives closer to you. But these options that will enable you to use less gas take time. So you are not very responsive in the short run, but with time you become more responsive. Most goods are like this. More time means more elastic. Okay, let's do another problem. Suppose the price of table saws increases sharply and stays high. What will be more elastic, the demand for table saws this month or demand for table saws in a year from now? The answer is this month. Table saws are an example of durable goods. Recall that with durable goods, more time means less elastic. Since the stock of durable goods, that is the total number that currently exists from previous years of production, far exceeds the annual rate of production. When the price increases, it is easy for consumers to avoid purchasing a new table saw by relying on the existing table saws. When we say stock, we do not mean the number in stock at a store. We mean the total number that exists throughout the entire economy. The 1941 Delta Unisaw depicted in this image is part of the stock of table saws. So in the short run, there is a sharp change in the number of saws consumers purchase new. They make do with the current stock of table saws in the short run. However, in the long run, the 1941 table saw keeps getting older. Eventually, its owner may get tired of repairing it and may eventually buy a new one despite the higher price of table saws.